Good morning, afternoon, evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we're going to be wrapping up logarithms, and we're going to learn how to solve exponential and logarithmic equations. Pretty easy if you remember how to expand and contract the log properties that we learned yesterday, okay? So we wrap it up. Hopefully you guys have realized that logs, although they look a little bit intimidating, they're actually quite simple. Let's first talk about an exponential equation, gentlemen. An exponential equation is an equation, as we know, that contains the form b of cx. Okay, you have a base to some power and sometimes multiplied by another power, such as a equals b to the cx, where the exponent includes a variable. In this case, the c could be an actual number. Well, that's weird. The c could be a number, and the x is the actual variable. Okay, so you can have a number and a variable. You can use logs to solve exponential equations. In fact, you have to. There's no other way to do this. You can use exponents to solve logarithmic equations. So it's vice versa. When you have an exponential equation, you're going to use the logs to get rid of that base. When you have a logarithmic equation, you're going to use bases. You're going to raise the logs to become a power to get rid of the logs. Let me explain what that means before you start looking at me and saying, what is this man talking about? Okay, here, okay, let's see what we can do for this particular case here, guys. Basically, you have a 16 and an 8, but what can I break that 16 down to have a common base? I'm sorry? Try more than 4 squared. 2 to the 4th. So this becomes 2 to the 4th times 3 to the x equals 2 to the 3rd. When you're solving equations that have a common base, you don't need to use log or exponents because we already know that property, right? I believe we already learned that property. Whenever you have the same bases, I can cancel out these two. And it becomes now 12x equals 3, x equals 1/4. Now, you may be wondering, okay, that's really cool. I like it. I'll accept it. Why, Mr. Morrow? Why? Let me explain why. Don't I have a base of 2 here, brothers? Right? So guess what? Remember the power of properties of equations in general. Whatever I do to one equation, I must do to the other equation in order to keep a balance, correct? Well, what happens, gentlemen, if I go like this? If I multiply this by a log base 2 to both sides? What happens? What happens with log base 2 and this 2? Don't they cancel? Dropping down the 12x. What happens to this 2 and this log base 2? They cancel, dropping down that 3. That's why this occurs. So when you already have the same base, you can go ahead and cancel out the bases and drop down the exponents. Do you have to show me why, how you did it with the log? Not when they're the same base. Okay? Not when they're the same base. If you want to, God bless you. That's awesome. Okay, what base is common to the number 27 and 81? 3, very good. So 27 would be 3 to the 3rd power times that 3x though, correct? You with me there, right, boys? And then 3 to what power is 81? 3 to the 4th. So cancel, cancel. 9, excellent. 9x equals 4 divided by 9. X equals 4/9. Excellent, brothers. Excellent. So it makes sense, guys. Promise? Okay, now, when the bases are not the same, solve the equations by simply taking the logarithm of each side of the equation. If m and n are not positive, but positive. Sorry about that. That is my bad. In fact, let's go ahead and correct that. That's kind of weak. Sorry about that. No excuses. okay, and m equals n. So you can take the log of each side of the equation if m and n are positive and m equals n, okay? Then the log of m, base m, can equal the log of base n. So let me explain what the heck I mean here. Solve each equation using different bases. Okay, so what's going to happen here? Okay, what do you think? What do you think is going on here right now? Can anyone think about what we're doing? I just want to see if you can think about it. What would you do? Okay, you want to just multiply a log. Do you think there's any simplification involved here at all? Anything that we can do here at all to make this a little bit easier? Factor out of 5. Factor out of 5? I don't think so. Hold on. All right, guys, check it out. I love, by the way, your thought process. I'm very proud of you, actually. Quite proud of you. We cannot turn 15 and 285 into any common base. However, using our log properties, can we log both sides? If I log both sides, doesn't this now become 3x log of 15 equals log of 285? Did you just see the awesomeness that occurred there? Do you see why I brought that 3x down? Because when I have a 3x and I log it and I have a power, doesn't that power go in front of my log, my brothers? So, okay, you guys got the calculators out. Divide log 15 to both sides, my brothers. See that? Pretty sick, right? So what would that be? Remember to use your parentheses, guys. So log 285, parentheses, divided by log 15. That's going to equal 3x equals 2.0873 when I round to the 10,000s place. Divide that bad boy by 3. X equals 0.6958, rounded to the nearest 10,000s place. So when I don't have any single clue or opportunity to turn them into a base, I can log both sides. Sir, my brother. Come again, Papa? Yeah, there's no change of base there to do. No. Yes, sir, my brother. Yeah, let's test it. Great point. Let's go 15 raised to the parentheses 3 times, remember we rounded it, 0.6958. I got 285.008. So I rounded it, and we rounded it twice. If we used the exact numbers, it would have given you 285. Does that make sense, boys? You promise? Promise. All right. Awesome. So how about here? Can I make 130 a base of 5 at all here, guys? So what on earth can I do to bring this sucker down? Log both sides. Absolutely. So 2x log of 5 equals log of 130. Divide by log of 5. Some of you thought I didn't know how to do it, did you? I know. Non-believers. No, I'm kidding. All right. So what's log of 130 divided by log of 5? It's 3.024. You know what? Let's just do this just to see how accurate we really are. Let's not round. Let's just go out to the 5th place. We'll round for the test. But let's just go to the fifth place here, just so I can prove that this is spot on. Divide by 2, my brothers. X is going to equal 1.51211846. Now, let me show you a little trick with your calculator. Let's see if this works. Go 5 raised to the parentheses 2 times second function answer, close the parentheses, bam, on the money, 130. Math does not lie. Okay, you go second function answer. Oh, you're okay. Does that make sense, guys? That second function answer button, that's what it's used for. Instead of me having to memorize this or write it down, I could just go second function answer. Where's the answer, Mr. Morrow? It's in blue right above the negative sign. Not the subtraction sign, but the negative sign. Okay, now, a logarithm equations. What did I? Oh, no, I didn't spell it wrong. I spaced it wrong. A logarithm equation is an equation that includes one or more logarithms involving a variable. Okay? Let's solve each logarithmic equation. Okay. In this particular case here, my brothers, pay attention. What is the base of this log, guys? So remember how I can log both sides to bring down the exponent? I can reverse it. I can raise everything to the 10th power here. And when I do that, guess what? What is 10 raised to the log? Cancels. I got 4x minus 3 equals, what's 10 squared? 100. Add 3. 4x equals 103 divided by 4. X equals 103 divided by 4. 25.75. Now, I like to prove things. Go log of 4 times 25.75 minus 3 parentheses equals, no, it equals 2 on the money. So, my brother, yes, I'm raising everything to the 10th power. So this is 10 squared. 10 to the log, these guys cancel out. I drop down my 4x minus 3. I'm raising this whole entire equation to the 10 power. Why? Because I'm dealing with log here. Come again? Yes, it is an exponent. Yes. No. What if it had a base of 2? For example, you would just do 2. You would raise to the second power. Yes. To check it, go log 4 times 25.75 minus 3, close parentheses, enter. Bam. Thank you, my brother. So here again, what's the base here? What's the base of log, guys? So I'm going to raise. I'm raising this to this power, my brothers. Those cancel, bless you. 3 minus 2x equals 1 over 10. Subtract 3 to both sides. Negative 2x equals negative 3 minus 1/10. That's going to be basically negative 29/10, right? I like to work with fractions and not mixed numbers. Remember, guys, this goes to 1. That stays as 1. And this down here goes to 10, so that goes to 30. So negative 29/10. Now divide by 2. Divide by 2. And then you have negative 29 tenths divided by negative 2. And what does that give you? X is 1.45. So again, the calculator is great here, but the calculator will do no good to you if you don't know how to set this up. Hey, yes sir, my brother. I don't know what you just said. What number becomes what? Yeah, Papa. Don't you see how I raised this to the 10? I made this the exponents. I brought all of this, I raised it up as an exponent because I used 10 as my base. Because 10 will cancel out the log, which is base 10. You feel me? Promise. Okay. Here, guys, this is expanded logarithm. How do I contract this logarithm? Very good, my brother. So this is log of x squared minus 3x. You with me? Equals 1. Log here is base 10. So I'm going to raise this to the 10th base. Please, please, please make sure you understand what I'm doing here, my brothers. Log 10 raised to the log cancels. I've got x squared minus 3x equals 10. Subtract 10 to both sides. Sorry, that looked like a 16. It should be a 10. X squared minus 3x minus 10 equals 0. This is x minus 5. X plus 2 equals 0. So x equals 5 or negative 2. However, you must check this. You can never have a log with an answer that is negative. What? As long as the log is even. Think about it. This negative 2 here. Can log of negative 2 even exist? No. You know there's a base of 10, right? 10 to what power gives you a negative answer? Nothing. No even number raised to any power will give you a negative number. It just will not work. You can't have negative answers as logs, ever. You can have negative exponents, but you can never have negative answers. So the only one that works is 5. Yeah, okay, wait, but what? Go. Okay, still if it's 9. 9 to what powers are going to be negative? Doesn't matter. Even or odd bases. As long as they're positive, which bases of logs have to be positive, no positive number raised to any power will ever give you a negative answer. Moreover, what about 2 to the negative third? That's going to be 1 over 8. Does that make sense, Papa? Thank you. I think I screwed up and I said it must be even. That's false. No log can have a negative answer. So you must test these answers out. Okay? But 5 works because 5 minus 3 is 2. Bingo. Log of 5. Bingo. Okay, next. Let's contract. So this is log of 6 divided by 3, which is, right? So this is, no, guys. Guys, it's 6 over 3x. Come on. So that's log of 2 over x equals negative 2. Raise it to the 10th power. Papa, this is not the answer. That's the exponent. Remember, guys, log base b of answer equals exponent. The answer can never be negative. Thank you, my brother, for caring. These guys cancel. I've got 2 over x equals 10 to the negative 2 is 1 over 100. Cross multiply. X equals 200. You're done, son. Bingo. And it works. Does that make sense, guys? Talk to me, guys. That's why I'm here. Talk to me, Papa. Okay, guys, what's 10 to the negative 2? That's 1 over 10 squared, which is 1 over 100. Thank you for caring. Good man. Does that make sense, guys? Go ahead. Whoever said wait, talk to me. That's what I'm here for. I cross-multiplied, bro. 2 times 100 is 200, and x times 1 is x. Why would I multiply the 2 to the x if I'm cross-multiplying? Thank you for asking. Thank you for caring. Anyone else, boys? This is what I'm here for. Come on. No shame. All right. Let's continue then. Now, natural logarithms. The function y equals e to the x has an inverse. It's called a natural logarithmic function. When you have log base e, it's the same thing as saying ln of x. Therefore, ln of e to the b equals b. If I have an e as a base, and I ln that e, since ln is log base e, these guys cancel, and it will equal b. Same thing, if I have an ln, and I raise it to an e base, these guys cancel, and I'm left with b. So the properties of ln are identical to the properties of log, except log has a base of 10, ln has a base of e. Natural and common logarithms are simplified and solved not he same way, but the same way. Okay? Let's talk. Let's just simplify these logarithms as a single natural log. 2 ln 15 minus ln of 75. This is literally ln of 15 squared divided by 75. 15 squared is 225 divided by 75. So that will equal ln of 3. Same as log. Ln is 7 plus 2 ln 5. That's ln of 7 times 5 squared. 25 times 7 is 175. Why are you confused, Papa? Same thing as log. Plus is the same thing as multiply. Same thing as the logs, guys, that we just learned yesterday. It's not like it is exactly the same, except it's ln, not log. This is a log base e. So this guy here for number C, or letter C, this will be ln of x cubed minus, so that's divided by 2x squared. So this would be ln of x cubed over 4x squared, which would equal ln of x over 4. Same exact properties. I promise you. I promise you. 3 ln x plus 2 ln y plus ln 5. There's going to be ln of x cubed y squared times 5. Let's clean it up. Ln of 5 x cubed y squared. Does that make sense, my brothers? Why? When you're adding, it's another representation of multiplication. The 3 went to the power because when you multiply and when it's an expanded form and it's multiplied, you contract it to become a power. Promise? Thank you, boys. May I continue? Okay. Let's do some equations now. We're going to run out of time, but we're going to at least do a few. Okay. I have an ln. What's the base of ln? So check it out. I'm going to raise this to the e base. Same as raising it to the 10 base, except now I'm raising it to the e. What happens when I have e raised to the ln? Cancels. So I've got x minus 3 squared equals e to the 4th. Go ahead in your calculator, go e to the 4th power. That should equal 54.598. Let's just take it to the 4th, but let's not round, so it could be more exact. Now, how do I get rid of this power of 2? Square root it. So now go second function, square root, second function answer. So I have x minus 3 equals 7.3890. Add 3 to it, and I'm going to get x equals 10.3890. If you want to plug that back in and check it, I promise you'll get the right answer. Does that make sense, boys? Talk to me, guys, because we're going to run out of time here. Yes, no, maybe, kind of, sort of. All right, let's do this one. Let's first contract it. So that's ln to the 6x equals 2. Raise them both to the e base. E to the ln cancels. 6x equals e squared. E squared equals, so I got 6x equals 7.38905. Divide that bad boy by 6. X will equal, just go divide it by 6. X equals 1.2315. Does that make sense, guys? Now look, real quick. We know how to get rid of the ln's. What about if you have an e here? Check this out. Subtract 2 to both sides first. Then I have 4. E to the 2x equals 14. Divide by 4. Divide by 4. Now I have e to the 2x equals 14 divided by 4 is 3.5. Hold on, guys. Now raise it to the ln power. The ln and the e cancel. So I've got 2x equals ln of 3.5, which equals 1.25276. Divided by 2, x equals 0.6263. So if I want to get rid of an ln, I raise it using an e base. I want to get rid of an e, I raise it using an ln base. Does that make sense, my brothers? Promise? God bless you. Have a great day. Hope you learned a lot. Bye-bye.